Today, we are going to discuss the integration by substitution. We have this technique to find some solution for the integration, which is written as a product of two functions. Usually, this type of functions or technique is used to simplify the integration. We know that from the chain rule that if you want to find the derivative of a composite function f of g of x is equal to, because this is a composite or composition of two functions and we need to find the derivative of this one. By the chain rule, we know the derivative for this one is written as f prime of g of x multiplied by g prime of x. Now the integration by substitution is just like the reverse process of the chain rule. Now if you want to use the integration by, or just explain the technique of integration by substitution, I'm going to take the integration for the chain rule. It will give me f of g of x dx is equal to the integration of f prime of g of x multiplied by g prime of x dx. And we know that the integration and differentiation are opposite of each other, so this one will cancel. So what I will have now, we'll have integration of f prime of g of x multiplied by g prime x dx is equal to f of g of x plus some constant c. Now, if we want to make it just easier and simplified, I will say let g, or okay, u equal to, let u equal to g of x, make it equal to the function inside the outer function f prime. Then if we differentiate with respect to x, I will have du equal to g prime of x dx, or dx can be written as du divided by g prime of x. Now if you write this back in the function, I will have integration of f prime of g of x is equal to u multiplied by g prime of x multiplied by dx, and dx is equal to du over d prime of x. Now this can be simplified. I will take d prime with d prime. So all what I have now is equal to integration of f prime of u du, which is equal to f of u plus the constant c. Just write it back. This is equal to f of u is equal to d of x plus the constant c. This technique is known as the integration by substitution. The main idea of this is to make the integration simpler, easier to find the antiderivative of the given function. Now to explain this with examples, I will say, okay, evaluate example number 1. Integration of f of x, not f of x, let's say I will have x squared minus 3x plus 5 to the power 10 multiplied by 2x minus 3 dx. Let's just investigate about this problem. Now I have multiplication of the function of two functions. The first one is x squared minus 3x plus 5 to the power 10 multiplied by 2x minus 3. Now we have two techniques. Either the first one, I will open the bracket to power 10, and that will be time consuming. It will take a long time. I need a lot of time to open the bracket. X squared minus 3x plus 5 to power 10. The other technique is just to see, do we have any relation between 2x minus 3 and x squared minus 3x plus 5? See, do we have any relation? I have x squared minus 3x plus 5. And we have 2x minus 3. What is the relation between the first function and the second function? We can see that the second function is just the derivative of the first one. If we take the derivative of x squared minus 3x plus 5, I will get 2x minus 3. And this is the idea of the integration by substitution. I want to make the integration easier, simpler. So I will see if I have any relation between the two functions, then I will use it to make the function easier to integrate. Now, we see that the 2x minus 3 is just the derivative of x squared minus 3x plus 5. In that case, I will use this part. I will say that u equal to x squared minus 3x plus 5. This will give me, if we differentiate, du is equal to 2x minus 3 multiplied by dx. Just differentiate, I will get this part. 2x minus 3 multiplied by dx. And from this one, I can find dx. dx is equal to du divided by 2x minus 3. Now, let's just substitute what we have now. So the function will be integration of u to power 10 multiplied by 2x minus 3 multiplied by dx. dx is equal to du divided by 2x minus 3. Now let's simplify what we have. I have 2x minus 3, or cancel with 2x minus 3. So my function now will be integration of u to power 10 multiplied by only du. And this is one of the basic integration. This is very easy to find now. And you know, for the integration, if I have u to the power 10, for the integration, we are going to add 1 to the power and divide by that number. So I will have u to the power 11 and divide by plus constant, because this is indefinite integral. So this will give me now, write it back, 1 over u is equal to x squared minus 3x plus 5 to the power 11 plus the constant c. So that's it. So you can see now the integration by substitution is to make the integration easier to find. Just to simplify the function, the integrand. Then integrate it and write it back in the last step. Let's take another one. Example number 2. Let's see, if I have integration of, let's see, that will be x multiplied by integration of 1 minus x squared dx. What is the integration of 1 minus x squared, or x multiplied by square root of 1 minus x squared? I need to simplify this to integrate, because I don't know how to integrate it in this form. This can be written as x multiplied by 1 minus x squared to power 1/2 dx. Now you can see this is similar to the first example. I have a function multiplied by another function to power something. So I will take what is inside the power as u substitution, will be my substitution. Because I can see that 1 minus x squared, if I differentiate, I will get x. If we take the derivative of what is inside this one, the derivative is equal to minus 2x. So I have x outside. That's why I will use u substitution, because at this I can use it now. So I will say let u to be 1 minus x squared. Take what is inside the bracket to be your substitution. Now differentiate, du will give me minus 2x dx, or dx can be written as du divided by minus 2x. Use this one now. Now write it in the function. So my function now will be integration of x multiplied by 1 minus x squared, we call it u, to power 1 half, multiplied by dx. Dx is du divided by minus 2x. Just simplify what we have. X will cancel x. So my function now will be, I will take minus 1 half outside, this one, I'll take it outside, then I will have integration of u to power 1 half du, which is equal to minus 1 half, the constant, keep it. Now for the integration, this is 1 half, so plus 1, I will have 1 half, plus 1 will be 3 over 2. So my function will be now multiplied by u to power 3 over 2 divided by plus the constant c, because this is indefinite. So I can write it as minus 1 half. The fraction down will be written upside down, will be written as upside down. So it will be 2 over 3. If we divide by a rational number, we just write it upside down. The denominator will be up and the numerator will be down. And I will write it back as 1 minus x squared to power 3 over 2 plus the constant c. I can simplify it more. 2 will cancel with 2. I will have minus 1 over 3 multiplied by 1 minus x squared to power 3 over 2 plus the constant c, and that's it. So this is the integration for the given function. Integration of x multiplied by 1 minus x squared. Again, the idea is just to make the integration easier to find using integration by substitution. Let's take one more. Number 3. Let's see what is the integration of x to power 3 square root of just 1 second. Okay, x to power 3 multiplied by x squared minus 1 dx. Let's find the integration of this function. As we did before, this can be written as x to the power 3 multiplied by x squared minus 1 to the power 1 half. So I'm going to take what is inside the power to be my u substitution. I will say let u equal to x squared minus 1. This will give me du is equal to, just differentiate, 2x dx. So dx will be du over 2x. Now my integration will be written as x to the power 3 u to the power 1 half dx. This will be written as du divided by 2x. Simplify. I will cancel x with the power 3, it will be 2. So in this case, I will have x squared u to the power 1 half multiplied by du. And now you can see that we still have x squared in the function. And this must be removed. After substitution, we shouldn't have any x in the function. So if I have x squared, I have to remove it or write it as a function of u, because I don't need any x in the function after the substitution. So we have to remove this x squared. This one must be removed or written in another form. See, we have u equal to x squared minus 1. From this equation, I will have u or x squared is equal to u plus 1. This one, if we move it to the other side, I will have x squared equal to u plus 1. This means now I can write x squared as u plus 1 multiplied by u to the power 1 half du. Now open the bracket. If we multiply u to the power 1 half with u to the power 1, add the power 1 plus 1 half is equal to 3 over 2. So I will have u to the power 3 over 2 plus u to the power 1 half du. Now I can integrate. Integrating means adding 1 to the power. I will add 1 for this power and 1 for the other power. So the first one will give me u 3 over 2 plus 1 is equal to 5 over 2. So it will be 5 over 2 divided by 5 over 2, it will be 2 over 5. Just write it upside down. Plus the second one, 1 half, plus 1 is equal to 3 over 2. So it will be 2 over 3. This is by division. We divide, I will get 2 over 3 multiplied by u to the power 3 over 2 plus the constant c. So just write everything back. I will have 2 over 5. U was x squared minus 1 to the power 5 over 2 plus 2 over 3 and the power, okay, and the power, or x squared minus 1 to the power 3 over 2 plus the constant c. And if you go back, I think I missed one thing here. This 1 half, it should be written out. I forget to write it. So I will have like this. This will be 1 over 2. We have constant outside. So we'll have 1 over 2 multiplied by 2 over 5 x squared minus 1 to the power 5 over 2 plus 2 over 3 multiplied by x squared minus 1 to the power 3 over 2 plus the constant c. So this is the idea of the integration by substitution. Make the function easier to find the integration. And usually in most of the problem you will find that the derivative of what is inside the power is written there. If you have any function multiplied by its derivative, use substitution technique to find the integration.